Nice to see you, nerds. Welcome to week 6, continuation of systems of equations. This time, you're going to learn 2 new methods for solving systems of equations. Last week, you got to see what a system of equation was, which was a couple lines on a graph that intersect. You found out that the solution to a systems of equation is that point of intersection, which I was super cool and showed you with that move a few times, karate chop. Both of the lines. So dumb. That's when one line and the other line cross, that point of intersection. This time you're going to learn how to solve them given 2 equations that aren't up there yet, but soon enough. In assignment 1 last week, you did 2 things. The first one being you were given 2 equations and a solution, and you plugged them in and checked if it worked or not. The second thing you did was you solved it graphically. We were given 2 linear equations. You created a graph. I can't stop doing it, I'm addicted. You found out where the intersection was and you wrote the ordered pair down. This time we're going to do it algebraically. And the first way we're going to do it is this method called the substitution method. All right, so how does substitution work? Substitution works by isolating a variable and then plugging in what that variable equals into the other equation. Why do we do that? As you can see, we have an x and a y and an x and a y. We need to be able to solve for one of them to be able to solve for the other. I know that doesn't make sense yet, but you'll see what I mean right now. Now, we talked last week and also at the beginning of this video what a solution of a systems of equation looks like. As we know, a system is the 2 lines and a point of intersection is its solution. And on the graph, we know the solution is one point, which can be written as an ordered pair. An x and a y. And as you notice, both equations have an x and a y. And when we did the first activity in Con last week, we were plugging into the x and the y to make sure that it made a true statement, right? If we plugged in something, it'd have to equal both sides in both equations. And if that was true, that means it was the solution. This time, we're given the equations and we're gonna have to algebraically manipulate them to find out what the x and the y are. They're not gonna give it to us, we're gonna create them. The way we do that this way, the substitution method, is we are going to isolate a variable, which is already done in this equation. We have x equals negative y plus 3. So we know x equals something. And what we're going to do is, in the other equation, we're going to plug in, we're going to substitute in, instead of x, what x equals. Now, why would we do that? Well, as you see in both equations, we have 2 variables, which we can never find the answer to what one equals without having the other one. Right here, we have x equals negative y plus 3, so the y is still involved. What happens is when we replace this x with the negative y plus 3, we are now going to have a way of finding out what y equals explicitly by just doing multi-step equations, something that we did at the beginning of the year. All right, so let's substitute in x with negative y plus 3. We're going to plug in negative y plus 3 in place of x. That would be the substitution, allowing us to solve for y. So we have 15, but no longer x. We're going to put in negative y plus 3 plus the rest, 31y equals negative 3. All right, doing multi-step equations, we know that we're going to have to distribute our 15 first to everything in the parentheses. So we're going to have negative 15y plus 45 plus 31y equals negative 3. All right, next we're going to combine like terms on the same side. We have negative 15y and 31y. That will be 31 minus 15, which is 16y, plus everything else. Now we just have a 2-step equation where we move the term that has no variable using either addition or subtraction. In this case, it's going to be subtraction. And then we're going to divide by what's with the variable. So it says plus 45, so we do inverse. So subtract 45, and then we're going to have 16y equals negative 48. Last step is to divide both sides by 16. And we're going to have y equals negative 3. So for our ordered pair, we found the y coordinate. We know it's going to be negative 3. Let's find the x. Now here's the quick part. We already know what y equals. We just solved it. We know y equals 3. And we can plug it into either equation to figure out what x equals. But one of them is way quicker than the other. Which one do you think that is? This bottom one. X is already by itself. So if we take in negative 3 and plug it in for y, we'll just have to do a quick equation, a couple steps, and boom, we'll know what x equals. So let's write it out. X equals negative y, but it's not going to be y now, it's going to be negative 3, but negative y plus 3. Now, what's negative 3? Two negatives equal a positive, so this becomes x equals positive 3 plus 3, which means x equals 6. So our ordered pair is 6, negative 3. All right, so that's what the substitution method is. And all 4 practice problems, they're going to give you 2 equations. One will have a variable already isolated for you. So all you have to do is follow the steps that I showed you, and you'll be able to quickly come to find your ordered pair solution. All right? This is the Father of the Year saying, love you, miss ya.